This is our last example in section 7.2. Suppose the wait time for teller service at a bank approximately follows a normal distribution with a mean of 5.6 minutes and a standard deviation of 2.1 minutes. The bank advertises that the majority of customers wait less than 5 minutes. What percent of their customers actually wait less than 5 minutes? Round to one decimal place as needed. Let's see what we know. All right, we know mean 5.6. We know standard deviation 2.1. So what are we trying to find? We're trying to find a percent. Percent, probability, proportion. That means normal CDF. We're not looking for an X value. We're looking for a probability or a percent. Okay, so let's sketch our normal curve. Label the mean 5.6. Okay, what percent of their customers wait less than 5 minutes? So 5 minutes would be just on the left side of 5.6, and less than 5 would be this area. This area is the answer to that question. It's the proportion or the probability of waiting less than 5 minutes, or the change it to a percent, multiply by 100, the percent of customers who wait less than 5 minutes. Okay, so our lower, this tail is completely shaded, so low to high, left to right, lower is negative 9999, our negative infinity. Our upper, the shading stops at, the highest value is 5. So the probability that x is less than 5, that's what we're trying to find. All right, remember normal CDF. We go second bars, that's our distributions. It's number 2. And see this, it already says negative 1 E999. What that means is negative 1 times 10 to the 99. So in other words, this is a very teeny tiny number. This is even much smaller than what we're using here. All we need to do is get way down in the tail. So you can leave that. If it initiates to that and you need negative infinity, that's what that is. So I'll just leave it this time instead of using negative 999. I don't have to change what I wrote there. I'll just leave it like that. Okay, all the way to 5. The mean is not 0, but 5.6. The standard deviation is not 1, but 2.1. Okay, so we've got everything just as it's written. And we will paste. So that's what we've entered. Enter. And we get 0.38754, so it won't round up, it's just 0.3875. Okay, so it says what percent of our customers, so 0.3875 times 100 will give us the percent, 38.75. But they said to round to one decimal place, so that's approximately 38.8%. So now we have it as a percent and we can write our interpretation. And we just use what it says the question is, just reword the question. The percent of their customers, the percent of their customers that actually wait less than 5 minutes is 38.8%. Now they were claiming, remember, that it was a majority. If you have 38.8% of the votes, for example, do you have a majority? What would you need to have a majority, by the way? That's almost 40%. Is that a majority? No. So you would need more than 50%. 50% would not be a majority, right? You need just whatever over 50% to have a majority. So this is definitely not true, what they've been claiming. If the bank wants to claim a maximum wait time for 75% of its customers, how long should the advertised maximum wait time be? They're asking me for a time. Remember, this is in minutes up here. They're asking me for a time. They're asking me for an X value. Here, they were asking me for the probability, right? The percent. So we use normal CDF. Now they're asking me how long. This is going to be an answer in minutes, so I'm going to need inverse norm to get an X value. If I want area, I use normal CDF. If I want a number along the number line, I use inverse norm. So let's sketch this out. What are they asking us here? We still have a 5.6 mean, but what they're saying is the bank wants to claim a maximum wait time, the maximum for 75% of the customers. So whatever this number is, 75% of their customers wait this amount of time or less. So which side of 5.6 would it be on of the mean? This is 50%, right? So I'm going to have to go over here somewhere and say there's some number X where 75%, 0.75% of the wait time is less than this number. What is that wait time that they can tell their customers? 75% of our customers wait less than this. Okay? So area to the left, I can look at my picture and see that needs to be 0.75. The mean, 5.6. Standard deviation, 2.1. I'm looking for an X value. Inverse norm. Second bars, go down to number 3. Area to the left, 0.75. Mean, 5.6. Standard deviation, 2.1. There's our values, and enter. Remember, this is minutes. 7.016. That's not a probability, right? Probabilities are between 0 and 1 inclusive. You can tell what I'm finding here is minutes. 7.016, or 7, it said to round to one decimal place. 0.01 would be about 7.0, right? So the average, it's the advertised maximum wait time should be 7 minutes. So they can claim that 75% of their customers only wait 7 minutes in line, which seems like a long time. But based on their data, that's what they would have to say, based on their mean standard deviation. Okay, last part of this, find the interquartile range. The interquartile range for the wait times is how many minutes? Okay, we've got to remember what that means. The IQR, remember what that is? It was Q3 minus Q1. Okay, what did we just find? 75% of the data is less than this. So this X is equal to 7.0, but that's also P75, is it not? Because 75% is the 75th percentile. And P75 has another name, right? Q3. So we need P75, which we already have, minus Q1, which percentile is Q1? Remember, it's P25. So all we need is P25, and we can make this calculation because we know P75 is 7.0, right? So down here, I'm going to draw a little picture, remind myself what I'm doing. 5.6. I want this value, Q1, where 0.25 or 25% of the values are below that number. That's what Q1 is, right? P25. So we're going to use inverse norm. We don't have our little blanks, but we can write this. The area is point to the left, 0.25. The mean, 5.6. Standard deviation, 2.1. And we're going to find P25 or Q1. Same thing, right? Okay. Second bars, inverse norm. Area to the left, 0.25. 5.6, 2.1, paste. Remember, this is minutes, 4.18. So P25, which is also Q1, let me see if we can get that on here. On the screen, running a little bit out of room, okay, which is also Q1, is 4.18, but they said round to 1 decimal place, so 4.2. So now we can come up here and we have Q3 minus Q1 and we get 2.8. So the answer is 2.8 minutes. Q3 minus Q1. We had Q3 from this problem because that's P75, and now we found P25, and we could calculate the interquartile range.